Good morning, student. I am V.N. Khairnar, PGT Physics from Jawahar Navodaya Vidyalaya, Shegaon, District, Buldana. Now, we are about to start our first chapter, Motion, of 9th class. So, before going to details of this chapter, Motion, or you can say about the discussion of motion, you might be knowing about the basic things which you have studied in the lower classes. So, let us recall the concept of motion which you have known in the lower classes. So, dear student, rest and motion, these two things are very important. That means when the object is at rest, so we will say that a body is said to be at rest if its position does not change with respect to its surrounding with time. Then you can say that object is at rest. So here the important thing is that the object does not change its position with respect to time. Or on the other hand, you can say that the object is in motion when its position changes with respect to time. Then you can say that that object is in motion. So this is the main difference between the object is at rest and object is in motion. So next point is point object. What is meant by point object? I will give you an example. Suppose the aeroplane is moving from Bombay to Washington. Then you will say that the distance between the Bombay and Washington is quite more as far as concerned to the size of the aeroplane. So you can say that when you will take the journey, then that time this aeroplane you can say as a point object. So if the distance moved by an object is very large as compared to its size, then the object is said to be a point object. This is the main concept of the point object. This point object concept you will that means you have to remember this one throughout this chapter. So keep it in mind about the point object. Next one, the type of motion. So the type of motion, first one is periodic motion, then oscillatory motion, projectile motion, linear motion, rotatory motion, and irregular motion. So let us see about the periodic motion. What is meant by periodic motion? Let us consider the example of the earth. The earth is moving around the sun. So the time interval is fixed, you can say. So that motion is called as a periodic motion, because when the object is moving, it is again moving in a regular time interval. That means its period is fixed. That particular type of motion is called as a periodic motion. Second one is your oscillatory motion. So let us take the example of pendulum. So when the pendulum moves back and forth in a regular interval of time, then that is called as the oscillatory motion. That means oscillation must be there and the time period is also fixed. So that motion is called as the oscillatory motion. Projectile motion. For example, here you can say when the object or the ball, if you throw in air, then it will travel the path, and that path is nothing but the projectile motion, or that motion of the ball is nothing but projectile motion. So when you will throw the ball from horizontal direction from one position to another position or one point to another point, then that motion of an object is the projectile motion. Then linear motion. Linear motion is nothing but the straight line motion. Linear means straight line. The linear motion is nothing but the straight line motion. When the object moves in a straight direction, then that motion is linear motion. Then next one is rotatory motion. Rotatory motion, you can see this figure. Here three different figures are shown here where the object is rotating. So that motion is called as a rotatory motion. Irregular motion. In irregular motion, you can see here the motion of the birds. When the birds are flying, then that time you can say that that pattern or the movement of the bird is nothing but the motion of the bird is irregular motion. So these are the different types of motion. Next one, already we have seen the motion. A body is said to be motion when its position changes continuously with respect to a stationary object taken as a reference point. So dear student, here the main concept is about the reference point. Now you see, when you are sitting in train, then you are at stationary with respect to the passenger which are sitting in the same bogie or in the same compartment. So the reference point plays a very important role. If you take any outsider, then as far as concerned to that outsider, you are in motion because that person is seeing you that you are in moving from one point to another point. So you are in motion. Now suppose both you are sitting in train, the same compartment, and the object is also outside, and if you will view all this scenery from the other planet, then you are in motion also. That means even though you are at a rest position on the surface of the earth, but you may be motion when you will take the reference point as a planet. So this reference point is very important. So when the position changes of a car continuously with respect to the stationary object like house, trees, etc., then the car is in motion. That means here the reference point you have taken as a house, trees, etc. These are the reference point. According to the reference point, you are deriving whether the object is in motion or not. Next one, the main concept in this chapter is about distance and displacement. So distance, what is meant by distance? The simple definition is the distance traveled by the body is the actual length of the path covered by the moving body irrespective of the direction in which the body travels. Now you can take the practical example. Suppose you are moving from hostel to the academic block. Then as the distance covered by you or the actual path covered by you, that is the distance. It may be 100 meter, 200 meter, depends on how much is your academic block far away from your hostel. So that is the distance. Now the another concept is that displacement. What is displacement here? When a body moves from one point to another, the distance traveled refer to the actual length of the indirect path, whereas displacement refers to the straight line path between the initial and final position. Now as this is the new concept for you, that is displacement, let me explain you. Suppose you are having here point A and another point here, a B point. So if you move from A to B in this direction, you can move A to B from this direction also. You can move A to B in this direction also. That is nothing but a straight line path. So you can go from path number 1, you can go by path number 2, you can go by path number 3. So you can see here the distance travel in all the three cases will be different. But if you travel or if you join from point A to B, which is in a straight line, then that is the displacement. Now again I will have to focus you on this particular point. What is displacement? Suppose you are moving from hostel to academic block. Then everywhere in our Navodaya, there is a different path to reach to the academic block. But suppose that nothing is there and the hostel your starting point and your academic block where you are sitting in that particular class, that is the end point, and if you join these 2 points straight line or straight away, then you can say that is the displacement. So you can easily explain or you can easily understand that is the distance and displacement. Distance means you can go by this 3-way, but displacement you have to go in a straight line only. That is the displacement. Or you can say that here the displacement is nothing but a straight line joining the initial and final point. That is the displacement. Now the next thing is distance is a scalar quantity and displacement is a vector quantity. So dear friend, I will explain you about this scalar quantity and vector quantity. Now what is scalar quantity? Suppose you are going in market and if you want to purchase suppose 1 kg sugar. So simply you can say that to the shopkeeper, give me 1 kg sugar. So 1 kg sugar, that is nothing but the magnitude of that particular sugar which you are bringing to the home. So that is the scalar quantity. That means it is having only magnitude. On the other hand, displacement is a vector quantity. Now what is vector quantity? Having magnitude as well as direction. Both should be there. Then you can say that that is the displacement. Now in the previous case, I have told you the distance is, you can say you can go by path number 1, path 2 and path 3. But path 3 is the displacement. Why? Because it is having magnitude and as well as direction. So you can say that only when the displacement is a vector quantity because it is having magnitude as well as direction. So this is the main difference between scalar quantity and vector quantity. Once again I am telling you, scalar quantity is having magnitude only, no specific direction, and displacement is having magnitude as well as direction. So the distance and displacement, I think you might have understood these two things very clearly. Now the distance traveled by a moving body cannot be zero. You see here, suppose you will start from your home and you will move in one particular direction. Suppose here point A is here and point B is here. If you move from A to B, then this is nothing but the distance covered. If you move from A to B and again from B to A, suppose the AB distance is 500 meter, then you can say that in total journey will be 1000 meter, that is 1 kilometer, that is from A to B and B to A. That means the distance traveled by you is 1000 meter or 1 kilometer. On the other hand, the displacement is something different. What is the displacement? Now you see, starting point is A. If you move from A to B and again from B to A, it means that your starting point and end point will be same. So in this case, the displacement will be 0. Dear friends, you see, this is the important concept of distance and displacement. That means distance is never 0, but displacement may be 0. Displacement may be 0. Displacement, suppose you are moving from A to B only, then the displacement will be 500 meter because your starting point is A and end point is B, so the displacement will be 500 meter. But if you are moving from A to B and B to A, then you can say the displacement is 0. And if you are moving, if it is reference point here, and if you are coming here and again coming to the A point and moving in this direction, suppose you have moved 2 meter in this direction, then you can say that displacement is negative. So displacement may be positive, may be 0, and may be negative, depends on the situation. So I think you got the difference between distance and displacement. So here now the main thing about uniform motion and non-uniform motion. What is in by uniform motion? Uniform. All of you are wearing the uniform in the morning assembly or when you are attending the classes. What does it mean? It means that all of you are looking in the same dress. The same concept you can apply here also. When the body is moving or the body is in motion, then if it travels equal distance in equal interval of time, no matter how small this time interval may be. So once again I will tell you, a body is in uniform motion if it travels equal distance in equal interval of time, no matter how small this time interval may be. That is called as a uniform motion. Suppose you are moving from your hostel to academic block, and if you are started with covering the distance, equal distance in equal interval of time, for example in 1 second, if you are covering that means the same distance in each equal in each second, if you cover the same distance, and if it is in the same direction, if it is in the straight line, then that will become the displacement. So here the uniform motion means what? When you travels equal distance in equal interval of time, then that is called as a uniform motion. On this here, the distance time graph, this is the distance time graph of uniform motion in a straight line, that I told you, in a straight line. Example, if you drop a ball from the roof of a tall building, then the motion will be a uniform motion. Now see here, when you will draw a graph, we will discuss into detail about this graph in the next lecture. But here you can see this graph of distance and time, and if you plot here the distance time graph of that object which is covering equal distance in equal interval of time, then you will get the straight line passing through the origin. That means this is nothing but the linear one. So this type of graph you will get whenever there is a uniform motion of the body. On the other hand, second, non-uniform motion. What is non-uniform motion? Just you have to replace something in the definition of uniform motion. That means in uniform motion, the body travels equal distance in equal interval of time. Here you can say in non-uniform motion, the body travels unequal distances in equal interval of time. That means unequal distances in equal interval of time. That means keeping the distance, keeping the time interval same. That means 1 second, etc. But if you are putting your leg with different distances, or you can say if you are moving in a straight line, then different displacement, then you can say that is nothing but the non-uniform motion. So simply you can say non-uniform motion means if you are covering unequal distance in equal interval of time, then that is called as a non-uniform motion. See this graph of distance time graph of non-uniform motion. You got this graph a little bit like this one. Why? Because you have covered distance, unequal distance in equal interval of time. So here on the y-axis if you take the distances, and on x-axis if you take the time, and if you plot the graph of that readings which you will take, then ultimately the graph will be like this. The nature of the graph will be like this. Simply you can say the nature of the graph is not a straight line. That is the main difference between the uniform motion and non-uniform motion. In uniform motion you will get the straight line. In non-uniform motion you will not get the straight line. So these are the things which you have to keep it in mind. Next thing, that is speed, velocity and acceleration. Speed. So describing about the speed. What is speed here? Speed of a body gives us an idea of how slow and fast the body is moving. Suppose you are going on two-wheeler and you are riding this two-wheeler, then you can increase the speed or you can decrease the speed. So ultimately when you will increase the speed, then you can say that that bike is moving in a fast way, and if you are decreasing the speed, then you can say the bike is going in a slow way. So that means it will give just the idea how fast or how slow the body is moving. Remember dear friend, you are moving from one point to another point. Suppose you are going from one place to another place, one town to another town, then the speed may vary. That means you can say sometimes you can go in a fast way, you can go in a slow way also. So how fast and how slow, that defines about the, you can say, speed. Now speed is equal to, speed of the body is equal to distance traveled upon time taken. That is, speed is denoted by here v, and distance traveled is s, and time taken is t. Therefore v is equal to s upon t, or speed is equal to distance upon time. You can, that very simple formula you are knowing. So you see here the speed is nothing but the distance traveled in and time taken. If you are covered the distance, suppose if you are moving from one town to another town, suppose the distance is 400 kilometer. That 400 kilometer you are covered in 4 hours. That means you can say that the speed of the body is how much? 400 divided by 4, that is 100 kilometer per hour. That is the speed of the body. So whenever the body is moving from one point to another point, how fast and how slow it is moving, that you cannot observe that thing in this formula. That's why the speed of the body is nothing but the distance traveled. Total distance traveled you have to take, and total time taken, you will get the speed of the body. Where in this formula I told you v is the speed, s is the distance traveled, and t is the time taken. Now the average speed. What is the need of this average speed? The average speed of the body is the total distance traveled divided by total time taken to cover this distance. So the average speed is equal to total distance traveled upon total time taken. Just I told you, suppose you have gone from one town to another town and total distance covered is suppose 400 kilometer, and the total time is taken 8 hours. So what is the average speed? So average speed will be 50 km per hour. So the bike has gone with an average speed of 50 km per hour. But dear friend, you cannot say that the body, or you can say that car or bike has moved this 50 km in every second or every minute. Why? Sometimes when the, what is the need of this average speed? Because when the body starts from the rest position, then the speed is 0. Then when the body starts, then at that time there may be some hurdles. Speed breaker will be there, some sort of disturbance will be there on the road. So these things you have to keep it in mind. So sometimes the bike or the bus may stop also. So sometimes it may run very fast, or the speed will be very fast. So due this type of motion, you can say this is nothing but the non-uniform motion, because the object is not covering equal distance in equal interval of time. So the average speed gives this idea that only how much is the speed of that body, speed of that object throughout the motion, but it cannot tell that how the object has moved from one point to another point. That means whether it has stopped, whether decreased the speed, increased the speed, etc., etc. I think you got this point now. So next one, average, that is uniform speed. Now see, uniform motion already we have discussed. On the same things, this is uniform speed. A body has uniform speed if it travels equal distances in equal interval of time, no matter how small this time interval may be. That means here uniform motion, that means equal distance in equal interval of time, and if the object is moving or the body is uniform speed, then it should cover equal distance in equal interval of time only. So that is the uniform speed. Next thing about the velocity. Now this is also a new concept for you about the velocity. Speed already you are something aware. Now the velocity. There is a little bit difference between the speed and velocity. What is that difference? Actually, when the object is moving from one point to another point, or one town to another town, or one city to another city, then we are not considering the direction. That's why if the body is moving 60 km per hour from one town to another town, then you can say that yes, it is moving with a certain speed, that is 60 km per hour. But you cannot say the path by means of which it has gone from one point to another point. So that means you don't have to deal with the path through which it has gone. Only just you will say that it has moved with the speed of 50 km per hour. Now in case of velocity, when the velocity means when the distance traveled by it, that means by the body per unit time in a given direction. This important thing, direction has come here. When the direction has come means, you take the same example, when the object is moving from one town to another town and that path is a straight line path, you can say straight highway, then in that case you can say that if the object is moving 50 km per hour from one point to another point in a particular direction or in a straight highway itself it indicates that it is having the particular direction. Therefore in this case you are having magnitude, that is 50 km per hour, and as well as the direction, which is nothing but a straight line or straight path, or you can say the straight highway. So that speed is now becomes the velocity. That is the difference between the speed and velocity. So we know that the distance travel in a given direction is known as displacement. Distance traveled in a given direction, that is the displacement. So in case of the speed formula, that is speed is equal to distance upon time. So here velocity is nothing but the displacement upon time. This is the very simple, or you can say the main difference between the speed and velocity. In speed you will get distance upon time. In velocity you will get displacement upon time, because velocity is a vector quantity and the object has moved in a particular direction. That means direction you have given here. In this formula, V is the velocity of the body, S is the displacement of the body, and T is the time taken. The SI unit of velocity is same as that of speed, that is meter per second. Both are having the same unit. Again, from this unit I want to tell you one thing. from the unit. Suppose I will take that the speed is having the same unit meter per second and velocity is also having the same unit meter per second. So from the unit you cannot tell the object has moved or whether the term is speed or velocity. But when specifically if you say that the velocity and its unit is meter per second, that means the object has moved in a particular direction with a certain velocity or with a certain speed in one particular direction. And on the other hand, speed also the unit is meter per second. So you can say that the object has moved from one point to another point, but you cannot specify about the path. That means path may be different. So that is the main difference between the, you can say, the speed and velocity. Next one about the uniform velocity. Again here word is coming here, uniform. Velocity already you know. You can define the velocity rate of change of displacement with respect to time, or velocity is equal to displacement upon time. But the actual definition is rate of change of displacement with respect to time. Now if the displacement of the object is equal in equal interval of time, then that is nothing but the uniform velocity. Means that once you know the definition of velocity, the rate of change of displacement. Now what is displacement? The distance traveled in a straight line. So that is displacement with respect to time. And again if you say that the displacement with respect to time, equal distance covered in a straight direction in equal interval of time, then that is called as the uniform velocity. So you can say that a body has uniform velocity if it is traveled in a specific direction in a straight line and moves over the equal distance. I may say that here instead of distances, you can say the displacement in equal interval of time. Or if you want to say about the distances, then you must say that in a specific direction. Already we have written the definition also. Thus, the velocity of the body can change in two ways. Now, how the velocity changes? Velocity changes in two ways. Now you see, what is the formula for the velocity? It is nothing but the displacement upon time. So either you change the displacement, so velocity will change, or you can say keeping the constant speed constant and by changing the direction. That means see, velocity is a vector quantity having magnitude as well as direction. So in this case, if you change any one of these two, then you can say the velocity will also change. So changing the speed of the body, suppose you keep the direction same, that means you are moving on a straight line. And if you are changing the speed, that means sometimes you are moving at 10 meter per second, sometimes you are 20 meter per second, sometimes 50 meter per second, again sometimes you are coming 25 meter per second. So the speed you are going to vary, but you are moving in a straight line. That means direction you are keeping here, but the speed you are varying. So that you can say that the displacement is changing with respect to time, thus the velocity also change. That means the changing the speed, you can say the velocity changes. Second thing, keep the speed constant. Suppose if I am moving on a circular path like this, if I am moving on a circular path, then on this path, if I will take the speed of the body, that is 60 meter per second, then no doubt every point here the object will move with 60 meter per second. So the speed is constant. But if at this every point the direction changes, you can say that to a circle the direction is always tangent to the particular point. If you are here, then this will be the direction. If you are here, then this will be the direction. If you are here, then this will be the direction. That means out of the two things, that is magnitude and direction, now I am keeping magnitude same, but the direction I am changing. So you can say that the velocity is also changing. So dear friend, I think you might have understood how the velocity changes. It depends on from its definition of the vector quantity, that is magnitude as well as direction. If the magnitude changes, then the direction will, if the magnitude changes, then the velocity will changes. If the magnitude is remain constant but the direction changes, then also you can say the velocity changes. So I think we have come up to this one, that is uniform velocity. Now the speed and velocity are not always equal in magnitude. The magnitude of the speed and velocity of a moving body is equal only if the body moves in a single straight line. If, however, a body doesn't move in a straight line, then the speed and velocity of the body are not equal. The average speed of moving body can never be zero, but average velocity of the body can be zero. So here the next and the last point about this acceleration. What is meant by acceleration? Now see, the acceleration is very simple. If you are moving on a bike, then on your right hand something is there by means of which you can increase the speed or you can decrease the speed. I am telling about the speed. And if you are moving in a straight line with certain speed, then you can say increasing the velocity and decreasing the velocity. Now you see, if you are moving in a straight line, if you are increasing the velocity and decreasing the velocity with respect to time, then the increase in velocity and decreasing velocity is called as a acceleration. Acceleration is simply rate of change of velocity with respect to time. That is called as an acceleration. Now how the velocity changes with respect to time, you can say that is nothing but the acceleration means rate of change of velocity with respect to time is called as acceleration. So acceleration's formula is very simple, that is final velocity minus initial velocity. Here is the formula: acceleration, final velocity minus initial velocity upon time taken. That is A is equal to V minus U upon T, where A is the acceleration of the body, V is the final velocity of the body, and U is the initial velocity of the body. We are using some different terms here, that is you can say initial velocity, final velocity, and in particular motion. So if you are starting from initial velocity, initial speed in a one particular direction, that is nothing but the initial velocity. And if you are moving after covering certain distance and you have reached the speed of suppose more than that of the initial speed, that is nothing but the final velocity. So and here the SI unit of acceleration is meter per second square, because rate of change of velocity, and velocity is nothing but your meter per second, and again rate of change of velocity, so again with respect to time, therefore upon second, so meter per second upon second, you will get meter per second square. That is nothing but the SI unit of acceleration. So dear friend, we have discussed about this acceleration. Now the uniform acceleration. What is uniform acceleration? A body has a uniform acceleration if it travels in a straight line and its velocity increases by equal amount in equal interval of time. Again the word is come here, that is uniform. So as uniform velocity, similarly you can go for the uniform acceleration. For non-uniform acceleration, a body has a non-uniform acceleration if its velocity increases by unequal amount in equal interval of time. Once you understood about the uniform velocity and non-uniform velocity, on the same track you can also explain about the uniform acceleration and non-uniform acceleration. The graph of this uniform acceleration is again a straight line passing through the origin. No doubt here the graph I have taken velocity versus time, that is nothing but acceleration, because rate of change of time. Here I have taken the speed in a one particular direction, so you can see here velocity, again velocity versus time, so you will get this graph is a non-uniform acceleration. So these are the two graphs which is showing the uniform acceleration and non-uniform acceleration. Then retardation or deceleration or negative acceleration. If you are initially increase the speed, then you can say that the velocity with respect to time is increasing, and if you decrease the speed, suppose you have applied the brake, then you can say that the velocity with respect to time is going to be decreased. So they can say that if it is decreasing, it is called as a retardation or negative acceleration. That is the main difference between the positive acceleration and negative acceleration. The negative acceleration is called as the retardation. Here average velocity, already we have defined about the average velocity, that is the initial velocity plus final velocity divided by 2, that is the average velocity. And here the average velocity we are using the bar. For example, here I have put here V bar is equal to U plus V upon 2. The bar indicates the average velocity. So I think in this particular session we have defined the different terms starting from distance, displacement, velocity, acceleration, uniform motion, non-uniform motion, uniform velocity, non-uniform velocity, uniform acceleration, non-uniform acceleration, and the graph about this uniform motion in particular cases. So I hope you have enjoyed this session, and in the next class we'll discuss about the graph, how to plot the graph of distance time, velocity time graph. Okay, thank you very much.